What follows is a brief presentation on why you should use weather normalization in your energy tracking projects. The presentation was developed by John Avina, Director of Abraxas Energy Consulting. There's a lot of buzz in industry about weather normalization, which is also known as weather correction, regression analysis, and tuning bills to weather. Let's look at an example to see why weather normalization is important. Suppose you were an energy manager and you installed a lighting retrofit in June of 2004. What we are looking at is a graph of what you would expect to see in savings for June of 2005. Before the retrofit, a lot of energy was used, and after the retrofit, you would expect to use less because of the modifications we made to our building. However, sometimes this year's bills end up higher than last year's. Does this mean you didn't save energy? Of course not, because if you had not installed your retrofits, you would have used even more. So what caused the extra usage? Well, it could be a lot of reasons. Let's consider the weather for Detroit in 2005. In 2005, Detroit had the hottest summer on record, with average temperatures about 3 degrees hotter than normal. 3 degrees doesn't really sound like a lot, but when you compare cooling degree days from 2004 and 2005, there is a huge difference. In June and August, there was over twice as many cooling degree days in 2005 as there were in 2004. Well, why do cooling degree days matter? Cooling degree days are proportional to the amount of cooling energy usage. And if you have twice as many cooling degree days, it means you're doing twice as much air conditioning. There were probably many energy managers in the Midwest who installed retrofits in 2005 and wanted to show savings, and they encountered a hot summer compared to the year before the retrofits. The savings they expected were not realized because of the abnormally hot summer. Managers have to present the results in a way that makes sense. They have to somehow take weather out of the whole energy savings equation so accurate savings can be determined. The way to accurately show savings is to correct for weather. This is why we do weather normalization.